Now in this video we will talk about a fixed point method for finding the root of the nonlinear functions, which is from week 7 question 3. So this function f of x equal to 3x squared minus exponential of x is given to us, and it asks us to find the root of this function in between the interval 0 and 1. Now the fixed point PDF is here from the lecture notes. The point is finding an appropriate function g of x from the function f of x by adding or obtaining x equal something which we call it g of x. So with this clear description from the lecture note, we end up to theorem 5. It says that if g maps the x from AB into AB, and if it is also the absolute value of the derivative of g is less than 1, by this constructive sequence we are able to find the fixed point of g, which it is equivalently equal to the root of the function f of x. Now let's have a look at the function. F of x is given like this, so we can write f of x. The aim is to finding the root of the f of x. We can write x equal like this, provided that x is positive. So g of x is square root of exponential of x on 3. So our job is to analyze that if g of x is satisfying in theorem 5. So g prime x is like this, and we can see that g prime x is monotone function, and we can plug the initial and end points of the interval, and we can see that the absolute value of g of x is less than 1. And since g is monotone, we again can plug the initial and end points of the interval, and we can see that g maps as 0 to 3 into 0 to 3. So g is satisfying the assumptions of the theorem 5. Now let's have a look at the Matlab code here. G is defined by function handle, n shows the maximum number of the loop that we want to repeat, and the initial point this time p0 is 1.2, and the tolerance is 10 to the minus 16. Error initially is infinity. And now let's go to the loop, and we will continue the loop until the error is less than the tolerance, and the error we defined, the error is here. Now we will repeat the loop until we will get the appropriate result. Now let's run the code here, and we can see that here the root is 0.91 with this initial point, which is 1.2. So let's zoom here, and we can see that the root that we have found for f of x, or fixed point for g of x, is 91, and 20 digits with this comment here. It is 20 digits within the 0 in first, and we see that there is also another root here, but we didn't analyze that interval because it's outside of the interval of 0 and 3. And actually it is very important to obtain appropriate g of x. So we can write g of x in another way here. So we can just add x on both sides of the f of x. So g of x can be defined as you can see here, but it is obvious that g is not satisfying the theorem 5. So the running code with this g of x will not work. And even if we change the initial value here, p0, let's change here, and we can see that it won't give us the appropriate result. Choosing appropriate g is very important for using the fixed point method for finding the root of the f of x. So for finding the root 3.72, which is given the question, let's have a look at the question here, the second part, and it asks that there is another possible root, so let's find that. This time the strategy can be a little bit different, so g of x can be equal to log of 3x squared, and this is the function with the initial value of equal 3. You can see that the answer is 3.7 is given to us with appropriate g of x.